Okay, so we're now talking still, I guess, about more reactions of alcohols. Now we're going to talk about oxidation. You may recall that in section 13.3 we talked about reduction of alcohols. I think it was 13.3. Reduction of, well, it wasn't of alcohols, it was reduction of carbonyls to make alcohols, right? This is what we talked about. Reduction of carbonyls to make alcohols. Do you remember the reactions that we used for that? One was adding hydrogen across the double bond, right? Can you see we have a new hydrogen here and a new hydrogen here where we don't have them over here, right? So we're adding hydrogen across the double bond, and we use palladium or platinum or cadmium or nickel maybe. The second one we used was sodium borohydride, right? And the third one we used was lithium aluminum hydride, which Klein abbreviates as LAH. Okay? So remember we did that before? All right, so now we're going to talk about the other way. Now we're going to talk about using alcohols for other things. So if we want to make a carbonyl from an alcohol, it's going to be an oxidation because it's the opposite of a reduction. All right, and recall now, an oxidation is increasing the number of carbon-oxygen bonds. This is what oxidation is, right? Or decreasing the number of carbon-hydrogen bonds, right? Those are oxidations. So can you see that here I have one carbon-oxygen bond, and here I've got two, right? That's an oxidation. Can you also see that here I have one carbon-hydrogen bond, and here I have none? Okay, so that's why it's an oxidation. All right, so let's go back here now. All right, so if we oxidize a primary alcohol, if we oxidize a primary, can you see, where's my pen? You've got two carbon-hydrogen bonds, right, that I can get rid of. And so if I get rid of one of them, then that's my first oxidation times 1. I'm going to be going from a primary alcohol to an aldehyde. Can you see that? And if I get rid of the other one, this is my second time, there's no more, there's no carbon hydrogens left, right? Then that is on the alpha carbon. Here's the alpha carbon, right? That's the alpha carbon. On the alpha carbon, then we're done, right? We have no more to get rid of, and that's when we have a carboxylic acid. Furthermore, if we look at it from the carbon-oxygen standpoint, you can see I've got one carbon-oxygen bond. Here I've got two. Here I've got three, right? So I've oxidized it. Okay, so oxidation of a primary alcohol can go all the way to a carboxylic acid. Oxidation of a secondary alcohol cannot, because, going back to my blue, I guess, because I only have one carbon-hydrogen bond and I can't get rid of any more after that. Okay, so there's no taking a ketone to a carboxylic acid under normal conditions. We can do it under something more extreme, but under normal conditions, we're not going to see that. All right, so for tertiary alcohol, we simply cannot oxidize it. Why not? Why not? All right, now let's talk about oxidation. So the most common oxidizing agent is chromic acid, and there's two ways to make that. Chromium trioxide in acid and acetone, or sodium dichromate, which is Cr2O7, right? So if I write that as my reagents, you can assume that what I really have is this. Put that in quotes with ears. All right. Now, chromic acid, when chromic acid reacts with alcohol, there's two main steps. So this is not a mechanism you're going to have to know. I show it to you because it's going to help you. right? Always the same reason. So first of all, can you see what we're doing? We've done things like this before. That's the reason I show it to you. We've done things like that before. You take this hydroxyl and you make something that looks like a leaving group. Turns out it is a leaving group. Okay? Different kind of leaving group though. It's not really taking the oxygen with it. And then we've got a nucleophile. Can you see this? I'm sorry, it's a base. It's acting as a base here. All right? Can you see it subtracting that proton? Okay? And it's affecting a reaction that's E2. All right? Very, very good for you to see that it's familiar. Again, I'm not expecting this to show up on a quiz or exam, the mechanism, but I want to show it to you because it's the kind of thing you've seen before. It can help solidify other things and frankly help make these processes make more sense to you. Okay, so what we've done then is we've taken a secondary alcohol in 2 steps, made a ketone. All right. Now, chromic acid is going to generally oxidize a primary alcohol to a carboxylic acid, and you can't stop it. So if you take where's my marker here? If you take this, let me rewrite this, okay? If you take a primary alcohol and take CrO3, this is what you're going to get. You're going to get all the way from there to there because you can't stop it. That's a hydronium. Can you see that? All right, and acetone. You're going to go all the way to a carboxylic acid. Primaries will go to carboxylic acids because they cannot stop here. All right. Now, if you want to stop if you want to make an aldehyde from a primary alcohol, you have to use something else called PCC, pyridinium chlorochromate. So this is going to show up in your reagents either as this or simply as PCC. All right, and PCC now, that will take a primary alcohol and go to an aldehyde. So, do you see I have a primary alcohol here? Right, because there's 2 hydrogens here. This is really a CH2. Okay, if I take PCC in DCM, dichloromethane, then what I'm going to get is an aldehyde. Right, it'll stop. But if I take a primary alcohol, if I do this, where am I here? If I do this with CrO3 and acid and acetone, what's it going to go to? If you don't know the answer to that, go to a previous slide. Go back and look again, okay? Now, if I take a secondary alcohol and treat it with PCC, it's still going to go, right, to the carbonyl compound, to the ketone. Why? Why is it not going to go to a carboxylic acid? All right. That's actually, you know what? That's a hard question. I don't want to ask that right now. Please don't even give any thought to that, really. It's not a good question. But if I take a secondary alcohol and treat it with sodium dichromate, it's still going to go to a ketone, right? So both of these work just fine to get a ketone if you're dealing with a secondary alcohol. All right. So practice with skill builder 13.7. All right, now predict the product for the following reaction. Okay, so if I have excess, not sure why it's drawn like that. I guess Klein does it like that. I'm generally going to say excess. Either of these means to mean the same thing. This is chromic acid. How do you spell chromic? Chromic acid, which is here, and acetone. What are you going to get? Pause the video, and I'll write the answer out here. Okay, I'm gonna suppose you paused the video. If you didn't, you're in trouble. I'm gonna find out. I'm looking at you through your camera. That's just spooky, isn't it? All right, forget I said that. What I'm gonna do when I see chromic acid, I see an oxidizing agent. Aha! right? Because all those oxygens, I see oxidizing agent. I go through here and look for something that can be oxidized, okay? That can be oxidized, that can be oxidized, and that can be oxidized, right? That's an aldehyde. All three of them can be. So chromic acid is going to give me the most oxidized thing possible. Well, there's only two, or rather, sorry, there's only one alpha hydrogen here. There's, just a second here, there's two alpha hydrogens here, right? And there's only one here. So this one, I can go through one oxidation step. It's going to go to that. 1, 2, 3. Sorry about that. I'm not sure what this is. I'm having trouble with my pen. 1, 2, 3. I didn't leave myself enough room. I'm going to stretch it over here. 4, 4, 5, 5. Right? I've got 2. So I'm going to... It's a primary alcohol, so that can go all the way to carboxylic acid. Right? 6. These are not in line. 6. 7. 7. And that one is already an aldehyde, but that can go to a carboxylic acid. Okay? Alright, so that's the answer. It's a little bit ugly, but that's the answer. Alright. Hope that's helpful.